Hi, I'm Sally and welcome to Learn Page by Page. In this video, I'm going to cover the art of balancing chemical equations. I'm going to show you how we get from this to this. And it's a method that was taught to me during my advanced chemistry teacher training by a professor in organic chemistry. This is a method that professional chemists use. I haven't seen this method on YouTube. That's really what's prompted me to record it. I think it's the best technique. It makes sure you chase the missing elements and you will get it right every time. Perfect for GCSE and SATs and any other chemistry test which involves balancing chemical equations correctly. So let's dive straight in. So before we go into doing more advanced balancing equations, let's look at what we're dealing with. Let's look at the reaction of hydrogen gas with oxygen, which gives us water. Firstly, when we look at a chemical equation, you've got two parts. You've got the reactants, which is anything before the arrow, and then you've got the product, which is anything after the arrow. This kind of equation here, that's a word equation. You should be able to write a word equation. And this one is hydrogen gas plus oxygen gas. Now the arrow means gives. So that gives the product, which is water, which is liquid water. Then we have the chemical or the symbol equation, and that would be your letters for your elements. So here, capital H for hydrogen, capital O for oxygen, and H2O, the classic water symbol that most of us know. But what do you actually have? You have one hydrogen gas molecule. So as you can see here, you've got a hydrogen chemically bonded to another hydrogen. And that is why it's called H2. The same with the oxygen, O2. We have oxygen chemically bonded with a double bond to another oxygen atom, and therefore we have O2. The arrow gives again, and you're going to get H2O. But if you notice, we've got a problem here. We've got two hydrogen atoms here and two hydrogen atoms here. That's great, but we've only got one oxygen atom this side of the arrow, and there should be two. If you imagine all chemical reactions happen within a vacuum, nothing can get in and nothing can get out. Mass has to be preserved. There must be the same number of atoms in the reactants as it is in the products, and vice versa. And that's why we must balance chemical equations. So let's go ahead and balance this equation. The first thing you do is you look at the very first atom on the reactants, and you write that down. And here you can see we have a hydrogen. You just list the hydrogen. You don't list the oxygen. You don't do anything else. You just write hydrogen. Here you can see there's two hydrogens. You then go ahead and say equals 2. Now you move over to the products. Same again, you're going to write the H for the hydrogen, and that equals, here you can see there's 2. One there, one there. So now you look at both sides, here and here. They both balance. You can move on to the next atom. Your next atom is oxygen. Count how many oxygen. There's 2. Come over to the other side. Same again. O equals, if you look up here, we only have 1. And that's our problem. That's not balanced. So you write the 1 there, and then you've got to figure out how can you make this 2. The first thing to note is you can't change any of these little numbers, because if you change those, you would actually change the molecule shape. That's a water molecule and it's fixed. That's its shape. So you can't add a 2 here. That would be incorrect. The only way you can change the number of oxygens is by putting a big number in front. So if we put a 2 there, that means we then have 2 times anything in this molecule. So we will have what we wanted, which was the 2 times oxygens. So immediately we change that to a 2. That's good, that's balanced. But if you notice, what it's also done is it's doubled these hydrogens here. So we must immediately change those hydrogens. And all you do is you put a line through that, change it to a 4, then immediately come over to the reactants, and you've got to change this to a 4 as well. And the only way you can change that to a 4 is to come up where the hydrogen is and put a 2 in front of that. And then that becomes a 4, and now you can see it's perfectly balanced. So what we have here is we have 2 hydrogens, and we will have 2 water molecules. And then if you go ahead and count up the atoms, you have 1, 2, 3, 4 hydrogens on the reactant side of the arrow, and you have 1, 2, 3, 4 hydrogens on the product side of the arrow. Oxygens, 1, 2 on the reactant side and 1, 2 on the product side. Now let's go ahead and work through a few more. Here we have a classic one which you need to know. So first of all, let's figure out what the word equation for this is. CH4, if you've done any of your organic chemistry, you'll know that's methane plus oxygen. Now, oxygen gas is always O2. That's the oxygen that we breathe. We have our arrow again. Remember, that means gives. Our products, we have carbon dioxide because there's 2 oxygens, and water. This reaction you need to know for GCSE, and it's known as a combustion reaction. It's burning. We're burning fuel in oxygen. And when you have enough oxygen, as you do with this reaction, this is called complete combustion. If you don't have enough oxygen, you'll be in incomplete combustion. That's for another video. So let's work again on balancing this equation. Look at the very first atom, and that's carbon, and you only write that down. Then check the number of carbons in both you're checking here and here. You can see here there's just 1 carbon. Because there isn't a number here, you've got to assume there's an invisible 1. So we have 1 carbon. Now go to the other side of the arrow. You could draw a line down the middle, but I don't really think it's necessary, but we do it for this example. We're still working on carbon, remember? Check your products and you can see there's 1 there and there's none there. Perfect, they balance. Now we can move on. Go back to the reactants, and now we're working on hydrogen. That's our second atom. And here we have 4 hydrogens. Go to the other side, onto the products. If you notice, we only have 2. So that does not balance. We've got to change this into a 4. And the only way we can do that is if we put a 2 in front of the water. Immediately, that changes it to a 4. And if you change this immediately, you won't get lost. You can see now we've got 4 here, 4 here. So our hydrogens balance. And now we can move on to the next atom, which was oxygen. How many oxygens we got? Always check both reactants. And I know that seems a bit strange because, well, you can see that's the only oxygen that we have. You'd be surprised when you go on to work out more advanced balancing chemical equations, you've got atoms that are hidden in different compounds. So get into the habit of checking both reactants and both products. Here we have 2 oxygens. Over the other side, we have 2 oxygens in the carbon dioxide. But if you also notice, we have oxygen in the water molecule. Now, because there is a 2 here, it's 2 times whatever's in this molecule. So there's actually 2 oxygens there as well. So in total, we have 2 in the carbon dioxide, 2 in the water molecules. That gives us 4. And we had 2 on this side. So we need to go ahead and balance that. And we do that by pulling a 2 there. That immediately gives us 4, and that means our oxygen balances on both sides. Now let's move on to a trickier one. This was the one at the beginning, if you notice. We have iron, metal, plus oxygen gas gives iron oxide, which is actually rust. We start off the same as before. If you want to try this without me, go ahead and pause the video. Okay, let's start with the very first atom, which was iron. And there's only 1 of those. Over to the other side of the arrow, you can see here we've got 2. So immediately we have to balance the reactant. And to do that, we put a 2 there, change that to a 2. That's balanced. Now we can move on to the oxygens. You see here we have 2 oxygens. Over to the other side. What have we got here? Well, we've got 3. So here we have 3 in the products, 2 in the reactants. So we're looking now for the lowest common multiple of 2 and 3, and that would be a 6. So we've got to turn this one into a 6, and we've also got to turn this one into a 6. And so the way we do that, to turn the 3 into a 6, we're going to put a 2 there, and over here, to turn this into a 6, we've got to put a 3 there. So there our oxygens are balanced, but what's happened is it's increased our iron because 2 times Fe2 will actually give 4. And if that's become 4, this needs to be 4. So we rub that out, pull a 4 there, change that, and that's perfectly balanced. Now we're going to work through one that's a little bit more complicated, and here you'll see why only writing individual atoms one at a time makes complete sense. What we have here is barium nitrate plus sodium phosphate gives barium phosphate and sodium nitrate. Let's work with the very first atom, and that was barium. We have 1 barium this side of the arrow. The other side on the products, you can see we have 3 barium. So we have to make this balance, and we're going to come over to the reactants. We pull a 3 in front of that, change that immediately. We have 3 barium. Now let's go on to the next element, and that's nitrogen. So what do we have? On this side, on the reactants, we have 1 nitrogen here, but there is this number 2 here. So that's multiplying everything in this bracket by 2. So that gives us 2 nitrogens, but we also have the 3 here. If we had 2 nitrogens multiplied by 3, we have to have 6 nitrogens. And therefore, we're looking for 6 on the products. Have we got that? By the look of it, no chance. We've got 1, and that is it. For that to balance, we have to put a 6 in front of the whole compound of sodium nitrate, and that would mean that balances. Now let's move on to the oxygens. Oxygens can be like a bit tricky in some of these big equations. You can get some big numbers. Let's look at what we have. Well, we have 3 inside the bracket. There's a 2 outside, so 2 times 3 is 6. There's also this 3 here, so 3 times 6 is 18, but then look at the sodium phosphate as well. We've got 4 here, so we had 18 plus 4, 22. Now let's check the products. What do we have? We have 4 here, multiplied by that 2, that's 8, and then we have 6 multiplied by 3, 18, plus the 8, that gives us 26. And if you notice, they don't balance. So we're going to go back over to the reactants. And how can we make this 22 into 26? We need 4 more. Let's put a 2 in front of the whole sodium phosphate compound, because that would give us the extra 4 here that we want. Immediately change that to 26, and that balances. Now the next element in the reactants is sodium. And what do we have? We have 3 sodiums originally, but we've just multiplied that whole compound by 2. So that gives us 6. Over onto the products. There's no sodium in the first product. In the second product, we have 6, perfectly balanced. Lastly, we're going to go on to the phosphorus. Let's rub some of these lines out. We have 1 phosphorus here, but we've multiplied it by 2. There's 2. Then over on the product side, what do we have? There's 1 in the bracket, which is multiplied by 2 on the outside, and that's 2. And that's finished. That's a perfectly balanced equation. And we're going on to do last one more. The reaction of ammonia with oxygen gas gives nitric oxide and water. So let's start off with the very first atom, which is our nitrogen. So N equals, check both reactants, and there's 1. Then how many nitrogens on the product side? Again, we have 1, so we're happy. That's perfectly balanced. Move over to the hydrogens. Here we have 3 hydrogens. Over to the products, you can see we've got 2. So again, we're looking for the lowest common multiple, which is 6. So we're going to turn that into a 3. That gives us 6 hydrogens here. We're going to make a 2 there. That gives us our 6. Has that changed anything else? Well, if you notice, yes, it's changed the nitrogens. So we immediately have to fix that. And don't leave it. Fix all this straight away before you move on to the next elements. So that made that nitrogen 2. Go over to the products and change this to a 2 by doing that. And now we can say everything's balanced. Lastly, we do the oxygens, and wait for this because this mucks everything up. What have we got? Well, we've got 2 oxygens here. we're going to come over here, and what have we got? Well, we have 3 times 1, that's 3 oxygens, and then 2 times 1, that's going to give us 5. And so the lowest common multiple of 2 and 5 is actually 10. And that's what we've got to do. We've got to make 10 oxygens. So the way we make 10 oxygens here is we're going to put a 5 in front of that. And here we're going to change this one to a 4 and this one to a 6. And that would give us our 10 oxygens. But if you notice, it's also mucked the nitrogens up. So here we had 2 nitrogens. Now we've got 4. So we've got to come over here and balance these nitrogens. That has to be a 4. And then also affected our hydrogens. We had 6 hydrogens. Now we have 12. We have to check we've got 12 here, and luckily we have. You see the 4 times the 3, we know we have 12 hydrogens. That one is probably as tricky as it gets, but I thought I would throw it in because it is actually one of my favourites. It's unlikely you're going to get anything like that in GCSE, but for A-level you should know how to do that. We should also clean this up. And lastly, one point that is worth pointing out is what these big numbers mean. Well, officially in chemistry, they mean there is 4 moles of ammonia plus 5 moles of oxygen needed to make 4 moles of nitric oxide and 6 moles of water. What is a mole? A mole is just another word for Avogadro's constant, which is a number. That's all it is. And that is 6.02 times 10 to the power of 23. So what this reaction is saying is you need 4 times this many ammonia molecules reacted with 5 moles of oxygen molecules to give the products. Knowing about the mole, and that is what they actually mean, isn't crucial, but it explains the whole meaning behind the art of balancing chemical equations. And that should be about everything. I hope that helps. I popped another video up on the screen, which I think you should find helpful. Any questions or any other videos you'd like me to put up, do leave a comment below. And thank you for watching. See you soon.